So, hi guys. So, today we are going to discuss a very good question in LeetCode, that is 496. The question is next greater element 1. So, let us understand the problem statement first, then we can code it and then we can see the dry case. Like, okay, we can explore this question, how we can solve with the stack and all the stuff. Okay, first of all, if you want to understand the problem statement first, so let us read the question so that we can understand this problem statement, then we can understand that stack, how to implement stack behind that. So they are saying next greater element. So what is meant by next greater element? So next greater element is a number which is first greater element to the right side of x. When you see the examples, then you can understand. First of all, see that they are giving two vectors. You can see over here in the problem statement also, they are including two vectors. Okay. So one is known as nums1, second one is known as nums2. Okay. Whatever the elements are there in nums1, the same elements would be there in nums2 and with some extra elements. Why? Because nums1 is subset of nums2. Okay, that means what, nums2 is a bigger set and nums1 is a smaller set, which will be like having containing all the elements as nums2 as well. Okay, that we have understood. So we need to return answer of I, which is next greater element as described below. So first of all, if you see clearly this nums1, if you see clearly this nums1 and nums2, what you will observe? So you can observe that we are getting output as -1 3 1. So see, let's see. Here in the nums one we have 4, and here also we have 4. So if you see towards the right side of the 4, we are not right side means this side. We are not having any bigger number than 4. So for that purpose, we are returning -1. Okay. Then if you see this one, so in the nums2 array we can find the one here, and after this the next number is 3. That is bigger than the one, so we are returning 3 here. Of course, we have 4 also, but the next bigger number we need to return. You can see the problem statement that only. The next greater element only we need to return the first number. After that, how many big numbers are there, like 4 and all, we need to ignore them. And finally we have 2 over here. If you find that in nums2 we also have 2 over here, and after that there is no number, so we can simply return -1. Okay, let us understand with the help of this some through the board. So let's take an example, like we have like nums1 is equals to 4 1 2, and we have nums2 is equals to 1 3 4 and finally 2. So assume that they have given these two arrays, and we already know that nums1 is less, means the number of elements in the nums2 will be more than nums1, because this is a subset, this is more. So all the elements are there in the nums2 will be, means the same elements will also be consisted over in the nums1, and vice versa is not accepted. Okay. So first of all, if you see the brute force approach, so first of all, I wanted to discuss a brute force approach so that you can understand what is the approach, or what is the main intuition to behind a problem to solve, or how to solve a problem. So in my case, what I will think is, first I will take a single element from the nums1. Okay, I will take it. So basically, I will take a loop and start traversing in this loop. And wherever I found this four element, I found here. So after this, whatever the next number greater than this, I will store. Let's say I will take a maximum like maxi, or larger, like any variable I will store here. Whatever the element larger than this current element. So the next element is 1. So I found 1 here, and I compare with the next larger element, which is 3. So immediately I will store this maxi, and whatever I am getting maxi elements, I will store in the answer vector. And finally we have lastly 2, and I found 2 here. So I will check to the left side, means sorry, the right side. There is no bigger element, simply I will return -1. Simply for this my these two I will return -1. So this is the way, a simple brute force approach that we can follow to obtain this the answer. So let's simply run a simple code, or the pseudo code for this pseudo code, so that you can compare, or like thing like that. So brute force approach. How can you just think of this brute force approach? Let's say we have for loop. For loop is going from 1 to like nums1 dot length, nums1 dot size. Okay. Yeah, you are running a for loop. Inside this for loop, again you need to run another for loop, which is running from yeah, let's say 0 and size -1. And here also we need to go from nums2 dot size -1, and another for loop here. And inside this for loop, whatever, so this is the thing that we need to follow for the brute force pseudo code. And if you observe that we have two loops, so as we're having the two loops, we can say the time complexity is order of n square, that what we don't want. So how we can approach like we have understood the brute force approach. Now we need to think of the optimal approach. So the optimal approach will be like we need to use the stack approach. So I will explain this stack, or like we can call it as this is as normal stack only that we can understand. So I will explain the main intuition behind that. Let's say we have this as the nums2, and we need to take a current variable which is one, the nums2. Okay. So for this we need to take a stack st, and we need to take another map. So why I am taking this stack and why I am taking this another map. So you can get to know in a while. Okay, I am taking this a stack and another map both as well. So I am taking this current means this value only. So first of all, instead of you can see over here, we have nums1 over here and nums2 over here. Let me copy this. So you can see clearly we have nums1 over here and nums2 over here. So instead of wholly depending on nums1, what we can do is we can simply uh, fully complete this nums2. We can go through this nums2 array fully once. Then what element had the bigger element on the right side, we can store them in a unordered map. So what elements we do not have the bigger element on that next side, we can store that in stack. And finally we need to fill this unordered map, and in the unordered map finally we can settle all the values. So after that, lastly we can traverse this nums1 array, and we can check all the compared values with the unordered map. So I'll explain the how this works. So you can see we have nums2, we have current. So as we have current one, this first element we can push into the stack. So the next step, the first step is completed successfully. So we are now going to the second step. So in the second step, we have, you can see clearly we have completed, we have pushed this one and now three. So we have current, in the current we have three, current is equals to three. And if you compare, the three is greater than one, which is in the stack. So we need to pop whatever the value in the stack, and we need to push the new value. Okay. So the next current value will become, you can see 4 over here. So you can get 4 inside this current, and you can check. So as 3 is less than this current value, again you need to remove that because 4 is greater than that. So you can remove these 3, and you can again place 4 in the stack. Okay. I hope this makes some sense now. And finally, this is the last step, and you can see at last we have 2. So as the current coming element is 2, which is 2 is less than 4, we can simply, without removing the 4, we can simply place 2. So what is meant by that? At last, we in the stack we are remaining with these elements. So what is this meant? If you clearly see this nums2 array, this nums2 array. So the nums2 array has one. So you can see clearly see that we have one to the right side we have a greater element. Three to the right side we have a greater element. But if you see 4 and 2 does not have any greater elements. So at finally we have the greater elements into the stack, and in the nums1 we can now traverse. So before traversing we need to store this information in an unordered map. So for one we can store three as means so it's pair key value pairs, right? So for three we can store four as its pair, and for 4 there is no greater element to the right side, we can store -1, and 2 also we do not have any greater element to the right side, so we store -1 here, because that finally we have two elements in the stack. For these two elements we are storing in this fashion. So I hope this makes some sense now. So I want to explain the time complexity for this. So the time complexity would be order of n plus m. Time complexity would be order of m plus 1. So what is this n and m, where n is the nums2 dot size, and where m is the nums1 dot size. Okay. And I also want to discuss the space complexity. I also want the space complexity to be discussed. Space complexity. So the stack will be taking the order of n space, and the unordered map, like unordered map, will be taking the order of n space. And for storing for the answer, it will also be going to take, means and finally we are having the answers in unordered map. We need to copy all that to a vector called answer. So all these three will be storing the order of n spaces, and finally we can consider. So generally in the answer we will not consider this answer part. So we will be going to say the complexity would be order of n, the final space complexity, and the time complexity would be order of n plus m, where n is this, m is this. Now let's code this up so that you can understand very clearly. So as you can see clearly over here, I have come to the lead code again. So for this problem, you have understood the problem statement clearly, I hope. Now let us code this apart. So they are giving us a vector num1 and num2. So we already seen that. So first of all, I'm going to take a stack. So let's say we are going to have, like, this is inbuilt inbuilt, as you know, in the HTL, in the C++ language. So if you want Java, you can get simply, you can check out in the Google or JavaScript, any language. There is no issue. You need to understand the concept. That's it. So I'm taking stack. Next, I am going to take an unordered map. So unordered map, I am going to fill with the key value pairs, right? So I am filling with in and I am going to map name it as map. So after this, I am going to run a for loop. So which will be going to scan the num2 arrays, these num2s, and we are going to have all this stuff into our unordered map. So I'm going to have the int num, and I'm going to scan the num2. So yeah, and inside this I'm going to run a while loop, and I'm going to check whether this stack is not empty or not. If the stack is empty, I'm not going to do anything. And with that, I'm going to check another condition also. The coming number, the coming number, let's say example is this, the one. Okay, here you can see the one. The one is coming here. That coming number, it should be greater than the stack top. Then also I am going, if any of the condition fails, I'm not going to enter this while loop inside this. Okay, then here I am going to place some value in the, if the I'm going to place in the unordered map. Okay, if I want code all, you can get to understand very clearly. So this is the step I am placing the number, whatever the next greater number. See, you can see one has greater number to the right next side, that is 3. So I am placing 3 inside this unordered map. That's all I am doing. So after that, I am just doing the pop operation. So after I am popping that, then what I will do is I will also do st dot push. I'm going to push this num. Okay, after this pushing num, then again I will, what I will do is I will going to run a while loop. So inside this, if stack is not empty, what I will be going to do is I will going to have the all the minus ones here. So whatever the numbers, you can see 4 and 2 does not have any greater numbers. So for that kind of numbers, stack will, as you can see, as you seen here, as you seen here, we are left with only 2 4 in the stack. So for this, in the unordered map, we need to fill with this minus 1. So that only I'm doing here. So stack dot top stack dot top, I'm doing here with minus 1. I'm going to fill that with minus 1, and I'm going to pop that out. Because I'm going to have completely, right, I'm going to fill all this map, and I'm going to traverse the whole this while loop. So that's why I'm writing that. So finally, I'm going to have the vector answer. Okay, so inside, again, I'm going to copy all the this answer from the unordered map that I had. So for that, I need to going to run a for loop. So in this, I'm going to have the int. So num, I'm going to say nums1. Right. Up to now, we have traversed all these nums2, and we have filled this unordered map. Now we are going to traverse this nums1, and for each element, for this 4, what is the corresponding this key value? We need to correspondingly see the value in the unordered map, and we need to fill the answer vector here. So I'm coming here, and I will say answer dot push underscore push back. So remember carefully, for you can see clearly over here, for the stack and queue, we will say push, and for the vectors we will say push back, right? So inside that, we will going to say map of that num, whatever the value of this 4, the correspondingly we have something in the unordered map here. So that value we are placing in that answer vector. Okay, and finally we are going to return that, return answer, and I am going to run that. So a simple typo error, that is, it's saying nums. It's not nums, it's num. This now it should go. You can see it's all successfully it has run. Now I will submit it. So yeah, you can see all the test cases that has been passed successfully. So all the 17 test cases has been successfully passed. So I hope you understood this video. Thanks for watching up to now. Please do like, share, and subscribe for this video.